Call the meeting to order and welcome everyone to the City of Kalispell's December 9, 2024 work session. This evening, we have one item for discussion: advanced wastewater treatment plant biosolids treatments and disposal alternatives review. Before we start, can I get a roll call though?
Councillor Fisher.
Here.
Councillor Hunter.
Here.
Councillor Nunnally.
Here.
Councillor Carlson.
Here.
Councillor Gabrielle.
Here.
Councillor Graham.
Here.
Councillor Dowd.
Here.
Councillor Dahlman.
Here.
Mayor Johnson.
Here. All right, Mr. Russell.
Yeah, Mayor and Council, as you know, biosolids has been a topic of discussion before this body multiple times before. We've actually had it in budget previously, looking at a large expansion of a potential composting facility. That was several years ago. That shifted during the dollars that were submitted for ARPA funding. County was looking at the potential of a septic facility and biosolids that would have replaced our biosolids facility that we were in planning for with a composting facility. Their plans changed and they went with septic only on it. So that leaves us in planning for the future. So with that, we kind of had to jump on it again really quick to start making some plans and looking at alternatives. And with that, I'll turn it over to our Public Works Director, Susie Turner, to lead off the staff report and start in on the presentation of alternatives.
Thank you, Doug. Good evening, Your Honor and Council members. Tonight, we will be reviewing the outcome of our biosolids treatment and disposal preliminary engineering report. Our presentation will include an overview of our current process, an explanation of the project needs, a review of 5 separate alternative approaches, including both monetary and non-monetary aspects of those alternatives. And finally, we'll be looking for some discussion and recommendations from council on an alternative so we can move forward with a project. We're going to have several speakers present information during this session, so introductions are in order. Aaron Losing, our wastewater treatment plant manager, will be discussing our current solids dewatering process. Scott Bucher, our project manager with AE2S. He is the project team lead with over 23 years of experience in wastewater treatment sector. And he is going to provide the in-depth review of the alternatives. Zach Freeling, engineer, is here to provide some engineering support on wastewater treatment alternatives. And also with us tonight, I did ask Dave Prunty, the Public Works Director for the county, to help answer any questions you might have as far as our interactions with the landfill. As we move forward with alternatives review, you'll see our main recommendation involves the landfill. So I asked him if he would come here and represent and answer any questions that council might have. So with that, we're going to just get started, and Aaron is going to review our current practice so you can understand what our proposals mean. There we go. Oh, you actually don't need this. Got it? All right.
Yeah, just moves super fast.
It does.
So, Mayor and Council, we have 2 processes for biosolids that we use in the facility. Our normal process is we utilize the volute screw press. We can run that 24/7. It's very easy to run, handles just about everything. We can handle that. Our normal pressing is RAS flow from the process, or WAS, wasted activated sludge. We press out of the process. We mix with digested sludge, and then it continues down this pipe directly over to the volute screw press. We typically run this about 55 gallons of waste activated sludge and about 20 to 22 gallons of digested 24/7. That works really well for our process. It doesn't slug load. It's just nice, smooth, continuous flow. It drops on this conveyor belt right here. which goes along this into the trucks. The other process is the belt press. This is original to the facility, started in 1992. We managed to keep that still running. We can also press digested on this and also waste activated sludge. The waste activated sludge utilizes this huge DAF unit, which injects a bunch of air into it, which floats the sludge to the surface. And then these big paddles, scrapers come across the top, dump it into a pit, which pumps to the belt press. So to do RAS, we have to have this big, huge tank to utilize the belt press. That pumps through the press onto the conveyor belt, which goes to the truck. This press is high maintenance, lots of high pressure water for washing, lots of moving bearings and stuff. So this is only utilized during staff hours. So the maximum we could run that during the normal operating day is about 6.5, 7 hours, maybe if we're lucky. And that slug loads the plant. So you got all that wash water that comes off that goes back into the process. So it's more convenient and better for the microbes in our process to actually run the screw press 24/7. And then if we have to pick up or clean a tank or something right now, we utilize the belt press to do that.
Okay. All right, so now we're going to shift it over and have Scott review our project planning and give me the.
Sure. Good evening, Mayor and Council. I'm going to back up one real quick. Just down at the bottom there, it says Class B generation of solids or biosolids. That's an EPA classification by their Reg 503C. There's only two classes, Class A and Class B. It's complicated, but in general, it just means how much of the pathogenic bacteria you've destroyed at that point. So Class B is very common, probably the most common class of biosolids in the country. If you go a little bit farther, with inactivation of the microbes, you can get to Class A, and you're freed up a little bit with what you can do with that product versus a Class B. So just keep that in mind because it'll come up a few times. So we started the project working with your staff to figure out what's current population, what's the basis, how much biosolids are produced per capita, and then doing population projections for the life cycle of the project. We chose 20 years, which is very common, and worked with city staff, and planning told us to use 2.5%. So that made things easier than us trying to project or come up with our own numbers. So that was nice. And then we project out the biosolids loading based on that. So this table is the summary, excuse me, of all that data. The first row there you see takes you through the project life 2025, 2030 out to 2045. And the dry tons produced. So this year or excuse me, next year, you would produce about 765 dry tons. So that's taking all the water out. It's just a way to make sure we're talking apples to apples and only talking about solids, regardless of what moisture content of that biosolids is. 867 all the way up to 1,260 at the end of this project life cycle in dry tons. The volume of those biosolids depend greatly on how much water is inside them. So 15% is roughly about where you operate now. 18 to 20 if you really push a good dewatering process as possible. So we included those numbers, and you see the number of trucks filled up per week drop from 6, 7 to 5 to 6, just to give you an idea of the volume of reduction. And if you can push that all the way up to 25%, then your volumetric production almost drops in half. So quite a difference when you remove some of the moisture from the biosolids. But one thing I do want to say here is 22, 25, that's really pushing the limit of what I would call dewatering equipment. To go above and beyond that, you start calling it drying or partial drying, and it's more equipment. It's a different approach. It's more intensive. It's more energy intensive, and but we'll talk a little bit more about that. So we talked a little bit about the project need, but the urgency was really brought to bear because of Glacier Gold's tentative plans to get out of the business, or at least the Olney bagging and distribution center. My understanding, and I'm not sure if this is the latest greatest, but some of their facilities may stay in operation, but they're ready to move on from Olney. And so that puts you all in a lurch. So city RFQ'd the project, and at the same time had a little bit of concern that with a little bit of PFAS that you have in your drinking water, perhaps there would be a PFAS issue on the biosolids. So that really led to the kicking off this project. Glacier Gold historically has provided about 70% of your biosolids disposal, with landfill being about the other 30% on an annual basis. As I said, they're closing down the Olney site. There was discussions of would the city be interested in taking that over or handling Glacier Gold, distribution. And honestly, that's a big apple to bite off. It's a lot of staff just to run something like that. So that wasn't really pursued here. And we did look at, in theory, what would it mean for the city to run its own composting operation, but it's a lot of contracts. It's a lot of management of farmers' land and relationships, and when can I get on your fields to dispose of this? What do I do in the meantime, et cetera, et cetera. So I just want to emphasize that that's kind of a big deal. Susie and others are working through those agreements and schedules, and currently they're essentially signaling that they'd like to be done in March of 2025. But there are discussions of ways to extend that. And I'd defer to Susie on that.
Yeah, even as recent as last week, we've been in discussions with Glacier Gold, recognizing that we can't just stop disposing of our biosolids in March. And Glacier Gold has been a good partner for us in the past. They have expressed that there are increased costs to what they're doing right now, and that they would like to increase their tipping fees if they were going to humor us and extend the contract for an extra year and a half until we get to the point where we don't need them anymore. So I do anticipate getting information back from Glacier Gold with increased tipping fees, hopefully to then get us to the next point where we can work with them and still deliver our biosolids to them until such time as we get new equipment or an alternative solution constructed and operating. So I'll be back in front of council probably sometime in January, February timeframe with a new maybe amendment to our current Glacier Gold contract and an increase in tipping fees for that. Where we stand right now is if Glacier Gold does not want to extend our agreement, is our agreement terms end in 2025. So if that's the alternative, then we will be looking at what we need to do with our biosolids at starting in March until such time as we can get alternative equipment in place or alternative treatment and disposal in place. More to come on those conversations, but they've been willing to work with us, and it seems like it's gonna, come out with an agreement in the end. But I'll have more final facts on that later as we further our discussions.
Thanks. So key takeaway there for the Public Works and Engineering team is time is not necessarily an emergency, but it's still, we need to move as quickly as we can. Just to circle back, I'm sure there's a lot of interest or concern over PFAS, and I'm sure you all have heard plenty on the topic, but the EPA decided to first address PFAS in drinking water and establish regulations, which they rolled out in April of this year. Second to come was biosolids, and their self-imposed deadline is the end of this year. So you may see their risk assessment and recommendations come out here pretty soon. We would have ideally liked to have those in hand by tonight, but we can't control what they do. We are, I would say, very confident that the EPA is not going to roll out numerical regulations on PFAS and biosolids. They want the states to do that. And that's just tends to be how they operate on the wastewater side versus water. So that's what we would expect in that document is more information for states to go about establishing their own regulations. Yeah, that's all I'll say about that right now. The preliminary testing that you all have done is really good news, actually. There is PFAS in your biosolids, but it is relatively low compared to utilities across the United States that have tested, certainly much, much lower than the biosolids that you've seen in the press that have caused issues to date. Whole different realm. I would venture to say that the biosolids that have risen to that level of harm are somehow been industrially influenced. You know, they're not what I would call run-of-the-mill municipal biosolids, or from communities that don't have a lot of heavy industrial PFAS users. The states that have started to initiate their own regulations are in general calling anything, 20 to 30 parts per billion micrograms per kilogram or less as not an issue. 20 to 100 as you can still put it on the land, but we want you to institute a pretreatment program, go out and find where that's coming from and start pushing back on whoever's discharging that. And then if you're over 100, most people, I would say, agree that that should not be put on the land until you figure out how to reduce that, either with a pretreatment program or some sort of PFAS destruction project. So, so far, based on the data we've seen, you're in that low category. So that was really good news.
Can I follow up on that? One of the things I saw in the press, and maybe this is what you're referring to, Montana PBS did a story about Glacier Gold specifically and tested their compost and found really high levels of PFAS. At the time, I was understanding, I thought we were the only ones that supplied Glacier Gold with biosolids, so it was necessarily us. But I understand now that perhaps others do as well. So when you talk about stuff seen in the press, are you referring to that in particular? And so your understanding is that we are low, and the Glacier Gold compost that was tested in that investigative reporting is not necessarily our biosolids contributing to that.
Correct. That was not, I don't know that was not your biosolids. I suspect it was not. The other sources of biosolids in that story, one in particular is heavily industrial influenced. In fact, has leachate from the landfill coming to the treatment plant, which is a whole different ballgame. We know there's lots of PFAS generally in leachate from landfills. Landfills are taking a lot of PFAS loads from rugs and old clothing and old chemicals, you name it. But no, and I don't, nobody knows the source, the exact source of the PFAS that was in the Glacier Gold that was in that story. The science on all this is still very young. There's still a lot of work to do. Just as an example, I've heard folks suspect that maybe some of that PFAS comes from sitting in bags that contain PFAS because it's a strengthener for the plastic. And it sits in those bags sometimes for a year or more on a pallet. And so there's a lot more work to do to find out where these sources are from. There's a lot more work to do to find out what are the risks of putting that on the land? How much of that makes it into a crop? And to back up a little bit, the EPA's risk assessment that's coming out this month is really focused on the farmer's risk at using those biosolids, and not the public's yet. I mean, it's just an incredible amount of data and testing and lab work that has to be done to get answers to any of this.
Great. That's very helpful. I appreciate that.
In regards to your question, as far as the sampling of the Glacier Gold compost, it's really difficult for us to really know what they sampled and what bag they grabbed it from. It specifically, I guess that question could be answered by Glacier Gold. They would know more than we would as a part of that. But they used to bag compost at the only site, but they don't anymore. It all gets shipped to kind of a more regional facility where it's mixed in. And it's our understanding, and I didn't know this till lately either, but they bring in maybe compost from other facilities and mix it into their, to develop different types of compost. So to answer your question, in reality, we don't know exactly what the answer is to that specific question. Glacier Gold would be the company to ask on that, or I guess whoever wrote the article.
Thank you.
And when that came out, there wasn't even a standard method published yet on how to test for PFAS in biosolids or compost. I'm not sure what method they use, but things are happening fast. We have a standard now from EPA that we're supposed to be using, everybody's supposed to be using, so we're talking apples to apples on the results.
Very important.
So Flathead County landfill accepts, as I said previously, about 30% of the city's biosolids historically. That equates to 200 to 225 dry tons per year, or approximately 2 trucks per week. The difference between those 2 trucks per week and the 5 to 6 that we were discussing earlier is that 30%. Not all of your biosolids has ever been going to the landfill. The folks at the landfill, Dave and others, had expressed some concern over taking what is typically 13 to 16% solids from you in perpetuity and taking all of it, because it is a lot. And they do accept biosolids. I believe they're pretty much mandated to, but they have sources coming from others that is drier or are drier. So they're interested in what can you do with that, essentially? Can you improve upon that? And there is a project there that we could do to incrementally improve that. Like I said, it's going to be really hard to get into that 25% and above range. It is a different animal. It's drying instead of dewatering. But there's a dewatering project that can be done to enable Aaron to slow things down and get a little bit drier. And that, therefore, is the interest in the initial agreement.
When you say that they accept from other sources that are drier, what's the difference there between ours and the other sources that they're accepting in terms of dryness?
Whitefish has holding ponds that they drain and then they let it dry for, I believe, approximately a year. So it's land, it's drying bed technology that is just a big platform, just a big area for the biosolids to dry with wind and sun and temperature, versus doing it mechanically with equipment.
And so they get to what percentage of dewatering?
I think the number we've been heard is
70,
70.
about 70%.
Oh, wow.
Yeah.
Okay.
So the landfill would like a drier product ideally, but understands that it could be a costly project, and so is willing to look at things more slowly and interim basis and see if we can find common ground on a product that doesn't interfere with their daily operations. I'll just put it that way. In this sort of interim period, if the landfill expressed difficulty dealing with your biosolids as is, and we are able to get this equipment in and improve it, then we would reassess at that point. But it would be a lot of communication of how's the last month's worth of biosolids been for you all to deal with? Are you able to incorporate it and work through it essentially together? I will take the opportunity to say that in general, the biosolids that are being landfilled in the US are dewatered, not dried unless that facility has, like I said, dewatering beds, which is really a choice they probably made 20 years ago to put in a large land area drying process versus a mechanical facility. So my point there being that there are lots of municipalities dewatering their biosolids to that 15 to 20% range and landfilling them without, I would say, causing undue harm to the landfill's operations. But it needs to be an open line of communications on what works for both parties. Aaron talked a little bit about your technology, which is on the left, the belt filter press in the upper left. That's about a 15 to 16% solids there, kind of a wet cake consistency. 13 to 14% on the volute press because it runs it through a little faster. It's hard to see there, but it does not have free water, which is important. There's a paint filter test that's exactly what you would think it is at that description, where it was meant to put paint on a screen and see if any dripped through. Well, it's become kind of a rule of thumb test for biosolids and whether or not you've done a decent job of dewatering it or not. And to my knowledge, the city's biosolids have never failed a paint filter test. So it's not giving up free water. It just has a little more moisture content in it. In the middle there, you see a 15%, which becomes, more of a mud. 45% becomes something that you can, squeeze and it would hold its shape like a moist dirt. And then on the upper right there is 40 to 75% in a solar drying facility. Starts to become essentially dirt like you'd find on a baseball field. 90%, it's really dry. In fact, sometimes you have to have provisions, not make sure it's not combustible or in an atmosphere where it could be combusted. It's dusty. At that point, we're trying to get it into a granule that'll hold together so we're not creating dust. And pushing this too far could be a dust issue for the landfill at some point too. So we kind of have some guardrails here on where we want to be. Beyond the landfill, we, like I said, when we started the project, there was a sense of urgency here from Glacier Gold shutting down Olney, also the PFAS. So we looked at several alternatives. On the left there are the criteria. They fell into two essential buckets. One was what could we do to maximize biosolids quality to facilitate land application. So essentially what that means there is get to a class A and destroy PFAS so that we, not necessarily because we think the regs are going to require us to, but just to know that we could do that project today and probably be free and clear of any future PFAS regulatory impacts. Or maximize dryness or improve dryness to increase landfill acceptance likelihood long term. So the alternatives we looked at fall in one of those two buckets. Number one is composting and land application managed by the city. So this is essentially taking over what Glacier Gold was doing for you, building your own composting facility and figuring out how to distribute it and manage those accounts. Number two is drying and landfilling all biosolids. Keyword there is drying. So we looked at first, when people say drying, they generally mean you're getting close to the 90%. You don't go out and buy that equipment and do that unless you're trying to get to a dried product. But in talking to the landfill, they were initially very interested in like a 40%. They were saying we don't necessarily need you to get to 90, but can you at least could you do 40? And the issue there is you're kind of in a no man's land. It's kind of a black hole, just because it's hard to build equipment that does that. You're generally either dewatering it to 15 to 20%, or you're buying an expensive thermal dryer and going all the way to 90. You can buy some thermal dryers or other tech and just sort of hot rod it or short circuit it and land somewhere in the middle. But there's not very many people at all doing that, and it's not without its own problems. But we looked at it anyway, and we'll show you what those costs were. Number 3 is pyrolysis and gasification with land application. Pyrolysis and gasification is the leading early technology for destroying PFAS in biosolids. It's still very young, but there are companies that have developed equipment to do this. Some track record, very short track record of some success, I would say. It's not quite tried and true, ready for prime time, I would say. And then very similar is supercritical water oxidation with land application. That is a very, very young technology that's being used to destroy PFAS in other industries, but does not have a single application yet in municipal biosolids. And then number 5 is pulling back to, hey, can we just improve our dewatering and landfill all biosolids and not destroy the PFAS? What does that look like? Composting, there are several different ways to go about composting of biosolids. There's sort of a heavily mechanized, shrink the footprint, get it inside a building approach. There's an old use a lot of land and just push it around in windrows approach. And then there's this sort of middle of the road approach here where you would build concrete beds and use a gore cover. In this case, that's the company that makes these, to just try to cut down on the amount of dust and odor that's produced, but also speed up the composting process a little bit to get to like a 35 to 50 day residence time underneath there.
Is there PFAS in the gore cover?
They are moving away. There has been historically, that's the same gore company that manufactures PFAS or has, and going to, I believe it's a polypropylene PFAS free product. Okay. Yeah, that was discussed numerous times with them of how do we get over that. The finished compost underneath there would be screened, which is not, it's an operator intensive process. And the better you screen it and the less plastics or anything you have in the amendments that you're going to have to use, you can't just compost biosolids. You have to add sawdust or wood chips or leaf litter or something and mix that in. Can greatly affect what you can do with the end product, whether you're able to sell it or you have to give it away because it's just not that aesthetically pleasing of a product or whatever it might be. So don't underestimate that. But then I think one of the biggest challenges there would be having staff essentially manage distribution of that composted biosolids. So you would have composting is intended, if operated well, to get you to a Class A product. So you can use it for lots of different things, including putting on your gardens at home. But I would emphasize the operator intensive and the time and temperature it takes to get to that Class A product requires more equipment or more land. If it's a really high quality, you could potentially sell it. If not, we know cities that have to give it away. I'll say it has relatively low operations, maintenance, and replacement costs, but that is relative to some of the very intense processes that we're comparing it to. It would still be additional employees, numerous additional employees that the city would have to hire to do that. It does have a long track record. The industry's been composting biosolids for a long time with success. The disadvantages are, as I've just said, it's operator intensive. You have to go get a woody amendment and you want to have reliable long-term sources of that amendment. You need a fair amount of land or a new building. You don't destroy PFAS with composting. It's going to require a lot of management, a lot of administrative time, and all of that. And it didn't come out as what I would call inexpensive. relative to some of the other alternatives here. We're at 16 million for that, like I said, kind of that middle of the road between a heavily mechanized composting process and a very farmer looking operation. But 16 million is a very large project.
I say before you move on the option one and also this maybe option two, but either one where it's kind of composting or distributing on land. In terms of the report that we read through, there was kind of a section on environmental impacts. And I do think if we're not removing PFAS, there should be some discussion in that report about the potential impact of PFAS on distributing that into the community. Just being I understand that we don't know what the PFAS level is in our product, but it should, I think, be a point of discussion in the environmental impact section of those two alternatives.
Okay, we will beef that up a bit.
Thank you.
Alternative two is drying. 2A would be full drying. 2B would be that sort of more experimental partial drying. The advantage of full drying is you greatly reduce the volume of the product. So you have lower tipping fees if you're going to the landfill, for example, or fewer trucks if you were composting going to your composting facility. But you'd have to add water back at that point, because composting ideally wants like 15 to 20% biosolids. But we would use for any of these technologies that are requiring heat. Aaron's got extra biogas out at the facility that we would plan on using no matter which technology we move forward with, which is nice. It is Class A inherently. You get that dry, you've killed a lot of bacteria, a lot of pathogens. So it's basically a slam dunk that you're Class A at that point. Obviously, the landfill, other than potential for dust, was comfortable with a dried product. They would just have to incorporate it a little quicker to keep it from drying and blowing around. But the disadvantages are a relatively high initial capital cost that you get there on your screen costs, I believe, over $4 million. And, you know, equipment costs are just a portion of total project costs because we need lots of ancillary mechanical, plumbing, heating, electrical, et cetera, building space to house it. So this quickly became slightly more expensive than the composting even. So it's a big project to do this. Generally higher O&M costs associated with these because you are taking a biosolids to 90%. So you can imagine the wear and tear on that equipment and the operator attention it requires. And even though you're using heat and drying it, you're not destroying the PFAS. Partial drying is, we define that as 45 to 80% biosolids. There's a couple of alternatives here. One is that short circuiting I referred to earlier. The other is this new process called E-load that seems to be trying to fill this hole or vacuum we've had in biosolids drying for a long time. But that E-load unit is only in, I believe, 2 plants in the U.S. And again, not a tried and true long track record product that we like to have in these situations. You would get substantial volume reduction. I showed you just getting from 15 to 25%. You drop the number of truckloads you generate in half. If you take that to beyond 45, then we're drastically reducing the volume of sludge coming out of the facility. We can use the biogas. We know the landfill would be comfortable with it, but it does have a relatively high capital cost. That equipment you see there on the left is not quite as much as a thermal dryer, but it's close. So multi-millions of dollars on the left-hand side of the screen there. It would not be a Class A final product because you haven't dried it out enough to the point that cells have desiccated and you've destroyed pathogens. And it does not destroy PFAS either. It's operationally challenging because you're kind of trying to hit that friable dirt sort of consistency there, which does not, machines don't really do well with that. So there's more attentive tentativeness needed from your operators. And like I said, that E-load technology is a little too new for our comfort. Pyrolysis and gasification. It's a really interesting process from an engineering standpoint. It, I think, is promising, but it is also brand new. These technologies are coming out of laboratories and they're trying to get to public works projects with them and have no idea how to execute projects in the US, for example. So there's a lot of hiccups with this. It is an intense, as you can tell there, lots of ancillary heating, exhaust gases produced, a lot of plumbing, mechanical, electrical, et cetera. Once you do get that going, the biosolids is the fuel. So you're heating it up to 1,500 degrees Fahrenheit and driving off the gases and then capturing the gases and using it to drive the process. So it is, like I said, it's neat and interesting, but it's very young. What you would get out of there would be almost a sand-like product. It's fully cooked, so you get tremendous solids reduction. But with all that said, you get 99-ish% PFAS destruction, but the capital cost for that is huge. It's an outlier. That equipment package alone right there costs $12 million. So you would need a really heavy, in my opinion, regulatory pressure to push you to go do a project like that. And again, you would be on the cutting edge at that point and going through lots of hurdles and hoops with that manufacturer to get that project completed. We don't even know if they're going to have the production capacity that potentially we're all going to ask of them to generate these for projects that do need some PFAS destruction. Supercritical water oxidation, similar, but this is a very specialized reactor where we're driving up pressures to, I believe it's 15 bar, 735 degrees C. So high temperature, high pressure, and you can destroy those PFAS compounds. So this is very specialized. This is going after PFAS. There are no municipal wastewater applications of this at this time. I believe there are landfill leachate applications of this technology. But again, very, very young. You would get a huge reduction because basically everything's destroyed at that point down to inerts. So you have that sand-like product coming out of there. 97% reduction in biosolids by volume, 99%-ish destruction of PFAS, a Class A final product, but not yet proven in our industry, operator intensive, and not something that your operators would work on, but something you'd have to call in specialists to work if there was a failure. It requires an additional screening facility. So you've got screening on your raw wastewater out at the plant before it goes into the liquids treatment processes. You'd need yet another one on the biosolids before you put it into that reactor. And it does require a small building. So expensive. Finally, alternative 5, which is just improving your dewatering operations a bit to try to get a product that the landfill can work with on a consistent basis and is comfortable accepting and having a long-term agreement with you to continue having you deliver it there. This would entail demolishing the dissolved air flotation tanks that Aaron showed you in that first photo. You have 2 out there. You would free up a lot of that space there. You wouldn't need that equipment anymore because right now it's just thickening waste activated sludge before it goes on the belt filter press. You would replace the belt filter press that's 34 years old at this point with that unit in the picture there. Get rid of that so you don't need the DAF anymore. And you would have 2 of these, the one you bought 8 years ago and this one. You would get a new polymer feed system with this, replace your WAS pumps to give the operators better control over wasting off the biological processes and sending that to your dewatering units. So the whole goal here is to get 3-4 percentage points more dryness out of your cake and have more reliability as well and redundancy. This alternative has the lowest life cycle cost. It uses a technology that your operators are already very familiar with because they're operating it 24/7 every day. That 24/7 operation, not always manned, is a huge advantage. You can't do that with many other dewatering technologies. Ripping out the DAFT units and putting in this volute press would also free up lots of space in the contingency event that you need to someday go to drying or something else. There would be a lot of room freed up in the biosolids facility out at the plant. Disadvantages, you might still struggle at times to get the dryness that you want based on normal operations, but this is true at any plant. Any wastewater treatment plant has process hiccups or has to take a tank down for inspection and maintenance, and those things can cause temporary decreases in the amount of dewatering that you get. And then, as we know, the landfill's a little, I use the word skittish at having to deal with a less well dewatered product. It's not a Class A final product, and it does not destroy any PFAS. So there's that. And of the projects we looked at, this one reduces the volume produced the least. So you're still going to have roughly the a similar volume of biosolids coming out of the facility. So this is all of the viewpoints of looking at cost analyses in one table. You got capital there in the top, so that's the construction project it would take to implement the project. So approximately $16 million for composting, $17 million for drying and landfilling, $55 million for pyrolysis and gasification, about $30.6 million for supercritical water oxidation, and about $2.9 million for dewatering improvements and landfilling. Your OM&R costs, so operations, maintenance, and replacement, are there in the second row, roughly in the same ballpark, other than the supercritical water oxidation being rather expensive because it is high pressure, high temperature, and the dewatering being the least. And that it's important to remember that cost is already something you're dealing with. You already have to dewater the biosolids. We're just looking at improving that process a little bit. Disposal costs are highest for that because we're taking the least amount of water out of the biosolids. So you see the cost of some of those disposal for the other technologies drop. OM&R costs and the present value costs rolled up into total life cycle costs there at the bottom. I would say the takeaway here was that capital cost still rules the day. It's not the amount of trucks that would be coming out of there with the dewatering improvements and the tipping fees at the landfill don't begin to touch the cost differences that are in that top row that are the total construction cost. So the difference between 2.9 million for dewatering improvements and a $16 to $17 million composting or drying project, that is a lot of hauling and a lot of tipping fees. For 20 years, it still comes out much, much less. This is just the same data, but on a bar graph to show we have a couple of outliers there being pyrolysis and gasification and supercritical water oxidation at $40 and $52 million. Our last alternative there is also in a different bucket, being much lower than the previous 4 or 5 alternatives that we looked at there, which we looked at 5 overall, but we have subsets of the drying and subsets of the partial drying. Just that's why we ended up with 8 alternatives on this graph bar chart. We wanted to look at factors beyond just the money. So we put this through a Kepner-Trigo KT analysis is a commonly used framework for helping folks make decisions. It's basically a way of establishing what criteria and factors are most important to you, and then putting importance factors on that, scoring those criteria and rolling that all up so that you can see what your preferred alternatives are versus just a gut feeling. So it's a way to track that decision-making process and verify that, yes, that is what I want to do. And it scores best because I've put it through this rigorous process and put all four of us folks up here, Aaron, Joe, Keith, and Susie, we scored it as well. And I'll show you those results here in a minute. The categories we divided into four over on the left-hand side of the screen were economic. So we still have that capital, OM&R, and net present value cost factored into here. Technical, so things like operability, track record, performance are in that category. Excuse me. Social would be impact. Sorry. Environmental would be things such as Councilman Hunter's point that there is an environmental risk of putting a product where you haven't destroyed the the PFAS on the land, for example. So 4 overarching categories, scored them all. Cut to the chase there. You can see that alternative number 5, dewatering improvements and landfilling, scored the highest. Relatively close second place was alternative number 2, drying and landfilling, followed by composting third, and then pyrolysis and gasification and supercritical water oxidation. I obviously fell to the back of the pack for good reason. So our recommendations and next steps at this point would be to proceed with the dewatering improvements and negotiating a landfill agreement while working with Glacier Gold to come up with as reasonable a way to extend their operation of Olney as long as possible to allow your staff and us and a contractor to complete the project. You don't have enough reserves on hand to fully fund that dewatering project. You would need to go with a bond, SRF or other. But it is a manageable, I would say an affordable project in terms of its impact on rates. And take kind of a wait and see approach towards it. Going down this path doesn't negate drying if you have to go there. In fact, it frees up space at the facility for that if that becomes an inevitability. Any questions there? Yes.
Drying is still a class B product.
Drying is class A.
Drying is class A.
Yep. Inherently, you dry out those cells, those bacteria die, most of them. So
Composting class A, drying class A.
Full drying class A. Partial drying is class B.
Okay,
So
that's right.
full dry, yeah, full drying class A, partial drying class B.
Thank you.
Yep.
Question about some timing questions. So we have Glacier Gold that might extend the contract. In terms of these different options, is there a difference on how long it would take to get them up and functional so that, we might be able to make the deadline with Glacier Gold, others we wouldn't, or?
yes, and honestly, dewatering is far and away the easiest to implement quickly. You would still have to pre-procure the equipment to move as fast as possible, which is not something that's always done, but it's a somewhat common move to jumpstart a project. You know exactly what piece of equipment we need from PW Tech. So we can move fairly quickly there and they can start, with shop drawings and if we approve those, start fabricating that equipment before you necessarily have all of your loan in hand and your general contractor or your construction manager at risk or however you decide to deliver the project. And the reason it's potentially fastest is it's the most straightforward, common approach. These other technologies, other than drying, are longer lead time equipment, more complicated equipment, manufacturers that have yet to really be put through multiple public works project deliveries in the United States. So expect hiccups and roadblocks and having to overcome a lot of that. This is very straightforward. We know how to do this. Not just we, I mean, the industry knows how to do this.
So then my other question is related to the landfill and kind of their the uncertainty there. And maybe we'll hear more about that. But right now they're willing to take the 20% roughly, but if they change their mind, it could change their mind in a year or 5 years or 10 years. If we put 3 million into alternative 5, how long would we say it was worth it? If the landfill changed their mind, we have to go with alternative 2 and drying to get a drier product. In other words, I don't want to throw $3 million away in alternative 5 only and turn around and have to do alternative 2 a few years from now because the landfill changed their mind about what they're willing to accept. And I'm wondering, how long do we consider it to be a good investment before we have to switch to an alternative 2, if you understand what I'm getting at there?
Yeah, I think it's a great question that we've all asked ourselves a lot in the last month or so. One aspect of that project that makes us feel a bit better about that is that belt filter press is 34 years old, I believe now. You would need to replace that anyway soon. So making the move to put in a new volute press when you're very happy with this 9-year-old but somewhat undersized volute press, undersized to handle all of your biosolids all the time with no backup is where I'm going with that. You would need to do something on the dewatering end anyway, even if you put in a dryer.
Yeah.
Okay, so that cost is there regardless.
The cost would be there regardless, because at some point we would have to improve our capacity for dewatering, moving forward, even if we had to move forward with a drying technology. Because as our flows go up, we would have to purchase a new volute screw press for that eventually anyway. So there really wouldn't be a throwaway cost. The throwaway cost would come if instead we moved to composting where we didn't need additional. Well, I take that back. We'd still have to dewater. So even with composting, we still need increased capacity for dewatering in the future. So,
well, that certainly makes it a lot easier.
Yeah.
Well, consideration then.
Would there be a cost though in the designing if we went with 5, knowing we were going to go to 2 in the future? Are there cost savings there that we would need to implement or could implement for basically planning going to dryer?
we could probably at this time, and you can correct me if I'm wrong, we could probably at this time design by taking out those 2 large DAF tanks, we can reorganize where we're putting the screw presses to in the future potentially bring in a dryer and locate them in the correct locations at this time, anticipating that we may need a dryer in the future. So I don't know if it'd be a cost savings, but it would be setting us up for future equipment and equipment in the future that might lead us down the drying path.
One step further on this landfill question, is it a local decision for our landfill, or are they falling under federal regulations on what they can accept in making an agreement with the landfill is one question. Number two, if we did decide to do some drying like whitefish, I understand that holds material for up to a year. Do we even have the space or ability to implement some of that as well? So two questions.
No, you don't now, and you can't just put that on the ground. It has to be an engineered, catchment and have drains and access for equipment, heavy equipment to come in and get it out of there when it's done. And it's, we didn't calculate the acreage that you would need for sludge drying beds, but it is acreage. And, I think if you, we have looked at the composting alternative, and could we possibly put that on your existing plant site, or would composting kick us out to Cemetery Road? I think you would be in the same dilemma with sludge drying beds of, can I jam this into the existing site? And if I do, what does that prevent me from doing with that open area next? What liquids, whatever you might need in 10, 20 years that you couldn't locate there or without moving those sludge drying beds. It is a relatively land and intense process.
And then the first question regarding the landfill's ability to make agreements with the city, is that just up to the landfill, or are there other regulations that fall into place?
It'd be, I don't want to speak for the landfill. We asked Dave to come to answer any of those questions on the landfill. They have their own regulatory requirements that they need to adhere to, and we respect that. So Dave will be able to answer those questions better than I can.
Thank you.
Good evening, Mayor Johnson, Council. Jed, to answer your question, the landfill could enter into agreement with City of Kalispell. That's not an issue. We have to follow the rules for disposal requirements from Montana DEQ. So two separate items, but our ability to make an agreement with City of Kalispell is very much a landfill decision, landfill board decision. We've never done this before, so certainly I would roll in the county commissioners into discussion, but it's an operational contract. And so I think that falls solely under in my opinion, under the preview of the solid waste board.
When you say you've never done this before,
we've never made a long-term disposal contract. We haven't done that. Now, one thing that I also have to take into account, please remember, we are a district. We serve the entire county. City of Columbia Falls brings us biosolids. Big Fork brings us pre-screenings. We don't get their biosolids. They're still land spreading. Whether they'll get to continue that or not is I would say certainly a question. Lakeside Sewer and Water, they also are playing that realm. Whitefish's drying beds are a lined facility where they're drying. So it's a clay liner, I believe. It's not a geosynthetic liner. I think that concept is probably very solid for years to come in their ability to dry that back, bring it to us for disposal. So I think from what my discussions with their public works director, I think they're pretty solid. They've got a brand new treatment plant and it's still going out to the drying bed. So I anticipate that's their concept for many years to come.
So I guess I have a couple questions from that, Jed. If we were to go with the drying system like this, Whitefish wouldn't be a problem. Columbia Falls, Lakeside, Big Fork, Summers, would they need to be fine, or could they benefit from a facility that we're talking about, and would we be able to help the county out? Because I know there's also septage that is also an issue. So
yes, Sam, I don't know if I can speak to what their plans would be and how they would utilize a regional drying facility, or are you talking about like the drying vessel? Right. I don't know. I don't know the answer to that. I'd leave that up to your staff if that would be a consideration for this concept.
I don't think that there would be a way to bring in their biosolids and mix it into a dryer that would fit into our facility. So it'd be an individual consideration. Each entity would,
Okay.
if they wanted to dry their biosolids, they could move towards that aspect. But
So I guess where I kind of go into this also would be then the septage from porta potties and stuff. I'm assuming that like, and forgive me, I am not in that wheelhouse, so I can't remember where we're at with that. Is that still going to be something that Lakeside is going to be?
I am not in that wheelhouse. That is not mine, so I don't want to answer that. I don't know that's not a project I have been put on to.
That works. I appreciate that. It's just a question that I have, even if you guys know that, because I mean, it is kind of a issue in our community is the septage, right? That's taken place. And so I know things have changed on that. So
Yeah, as far as I know, they're still under construction on the Lakeside facility or under
Okay.
agreement for it. You know, like I said, I'm not privy to those direct discussions, but I think they're moving forward
Okay.
within that.
so it'd be nothing that this would be impact, nothing.
Yeah, no,
there.
we wouldn't, actually, we can't handle septage.
Okay.
One thing, if I may, just so everybody understands, one of the issues why we don't know what we don't know. There's our problem at the landfill. So we've accepted about 30% of your biosolids, and we've worked with Aaron wonderfully to get it. It comes in at 8 o'clock in the morning. It's one of the first loads there. It gives us all day to process. I have to have enough garbage to process with the biosolids. If you've ever seen when it comes in at 13% and it comes out of the back of his trucks, it just flows. Doesn't stay in a pile. It flows. And so I have to take that with my equipment and literally paint it on the face of the garbage where we're working. And then we take more garbage on top of it and we mix it in. And if you see when we get a big glob, I'll call it, and our compactor gets into it, I just sit there and do this. It's so slick. It's so wet. I can't process it. So there's our concern. Our tonnages in the summertime are double what they are in the wintertime. Your biosolids production, I'm sure, goes up in the wintertime, but it doesn't do the same that my garbage does for differentials. I think you're pretty static when it comes for the production. Am I right, Aaron?
Yeah, we're pretty consistent year round. It doesn't have the highs and lows. It's
I got
pretty
the
steady.
high in the summer and I'm cutting half in the winter time for my tonnage. So if I don't have enough garbage, I got problems. There's where we want to learn in this preliminary concept we came up with of, okay, what can the landfill process? Because I've never taken as much as you're proposing to bring out to us. Aaron calls on holidays, on breakdowns, on Glacier Gold having issues, whatever it might be. And we always say, bring it out. Our job is to take your material, and we'll do that. I do have to take into consideration the other cities, the other treatment plants, and all of that. And the PFAS discussion is interesting because if all of a sudden any land spreading is gone, where's it coming? All to us. So there's where we needed a way in our discussions to cry uncle if we get 3 years into this thing and all of a sudden, everybody's got to come or whatever it might be. And I don't have the ability to process all of it. So that's our concern because we don't know what we don't know yet.
So, so option 5, we would be 40%.
No, nope,
Where
we
would we be on a percentage?
would be at the dewatering phase, trying to max out our dewatering 18 to 20%.
18 to 20%. So
Yep.
better than we are. So more, okay.
Better than we are.
But still,
And one thing I'll say, Aaron did a test load. We've had one test load. We think we were 18 to 20. Is that our guess?
That would be our guess.
And it was markedly different than 13 and 14. So our operator said, oh, okay, that helped. Now we'd love to see 20 to 25 is what there's our cushion. If we could get to that in your dewatering, we got way more comfortable with that 18 to 20 load that showed up. So again, I don't know what I don't know. And so there's the concept of, okay, what can we do here? So
is there a way to, and this isn't my wheelhouse. I don't know anything about this. So, when it comes through the dewatering process, I think we were talking about there was going to be possibly with number 5, the open area to go through and do a drying component to it. Does that mean you're adding something to it like a sawdust when you're doing that, when you're doing the drying, or is it
Just heat.
just heat?
For the most
So,
part, most technologies are heat. That one we look at.
so from what Mr. Prentice's saying, with it being really watery, slick and everything when it comes out, is there a way to add sawdust to that to go through and dry up some of that water to?
We did look at that. There are rumors of people using such things, desiccants, but we couldn't find an installation that's able to. You're having to meter that in with a hopper and something that can convey it at a trickle it in and get that product routinely. So most folks are not doing that. And honestly, I think what we're seeing here is the landfill's reaction to a 13-ish, 14-ish% product that is remarkably different than a 18 and above. It's the differences there are I don't want to say exponentially
So at 18,
different.
it's a lot better.
Yeah, it's not
Okay.
linear. It's not a linear improvement right there. Once you get to 60%, telling the difference between a 60 and a 70% would be very difficult for anybody in this room. But telling the difference between 13 and 20, I think most of us would be able to do.
Okay. Yeah. So I understand there's really no way to go through and incorporate what you're saying is to incorporate the sawdust or whatever into the product. But I was just,
Yeah.
thinking about all the lumber mills we have
Yeah.
around here, and I don't know what they do with their sawdust, but
Yeah. Yeah. In theory, you can do what you're talking about. It. You have to be very careful with, with PW Tech's equipment. Would they accept, us dewatering sawdust in addition to our biosolids? And you would also be producing more volume
yeah.
because you're adding that amendment.
So when we're looking at this project, you did bring up something interesting where doing option 5 allows you to then think about adding a dryer to the end of that, right? So when we get to that point where we have a dryer and the dewatering, could we have 2 different types of product that we're shipping to landfill? So we'd have some dry and some sludge. Okay.
That concept was explored, but it would be blending. So taking, an 80% plus off the dryer and back mixing it with let's say you just stuck with what you're doing now at 14% and mixing that together in a pug mill, they call it. It's just looks like a dumpster with a screw in the middle that spins it and mixes it. That's not a small thing either. That would end up being outdoors there, or we have to put some sort of shelter over it. And it's just another process for operators to operate and, be figuring out the ratio and.
Yeah, I wasn't actually thinking of mixing it though. I was thinking you'd end up with 2 types that you would be taking to landfill. One is some of it would be dried, and then some of it would be in the 18% range. Does that do you understand what I'm saying?
I do understand what you're saying. I guess I'm struggling with the why. You would.
I'm thinking like long term, like into the far future with projects. So initially, we do the project with adding an additional, going with option 5, and then, but we're knowing that we're trying to get to the dryer portion. So if we built the dewatering in such a way where we anticipated adding the drying at the end of that process, so that we didn't have to reconstruct the whole thing at the when we get to the drying phase. I'm just kind of thinking like we have a longer term project, which is to get to a dryer. But the short term is to add the dewatering. And it also would end up being less loads to the landfill. We'd be shooting for that over time.
Mm-hmm. Yeah. And I guess what I would say here is we would set up the conveyance to enable you to put dewatered product in the trucks or go through the dryer and put a dried product in the trucks so that if the dryer goes down, which happens, you're not dead in the water and you're still able to send dewatered biosolids to the landfill. So in principle, you would be able to do what you're saying.
Okay. Yeah, I was just thinking about it over time because the cost of the projects are wildly different, right? So you put the dryer out at a longer term capital project and then bring in the dewater because we need it now kind of deal.
Perhaps Whitefish wants to work with us and take some of our.
But I think it's important to note Whitefish produces significantly less biosolids than we do. I mean, we're a much larger plant than Whitefish, so it's kind of difficult to compare Whitefish or even Sioux Falls to the amount of effluent or solids that we produce.
Exactly.
You know, we're $3.2 million, or 3.2 million gallon plant, and they're not even a million gallon plant. So there's really, once we kind of are a little bit of a realm above them, and they fortunately have the ability to use their drying beds at this point. As Scott was saying, we would need acres of drying beds, which isn't necessarily a bad question. I mean, I think that's a great question, but we would just need acres. I think I was hearing conversation that maybe the city of Denver actually does that. So it's not a bad question. It's just the ability to have the acreage to be able to do that process. But you're also spending quite a bit of capital funding to set yourself up for those types of alternatives.
Yeah, I think if you asked me like 2 years ago where I would be on this, I definitely would have been on the composting side, just simply for the fact of the recycling notion of it and contributing to, soil productivity and all that. But the whole PFAS question comes in and just totally changes that equation. And even if you can address the PFAS, I feel like there's so much more unknown, phthalates, microplastics, medication that people are taking, and how is that getting into our waste stream of antidepressants and birth control and everything else that isn't even tested for. And I don't think that's down the line in terms of regulation, probably. That is just a whole unknown. So ultimately, that's what pushes me away from any kind of composting or reapplication on agricultural soils. And then there's this new technology, but to your point, super expensive and super new. So we don't know long term what it's like. I mean, if it weren't for that fact, I would be interested in exploring that more. But those two things are pretty significant factors.
Makes it hard to consider that because of those capital investments and the new technology. We just don't really know what we're getting ourselves into with those new technologies. We'd like somebody else to vet through those for a while first and then jump on that. I think, when we did biosolids testing for PFAS, we were pleasantly surprised on the low concentration that we had. So I think that's also a really good thing.
What was the number on that again? I think I missed that.
2 parts per billion, I believe.
For
2, and you were saying like 100 was the
100 has been used, I believe, by Michigan and one other state who's escapes me at this moment, that have gone out and proactively ahead of the EPA doing anything said, we're going to set our own numerical limits. 100 seems to be being adopted as a general rule of thumb of don't put that on the land. It's less than that. It's way less than that, like 20 parts per billion. We are exposed to higher levels of PFAS from our everyday life than we're going to be exposed to that product. Anywhere in between those two, let's maybe do a little bit of both. Keep going to the land, but be chasing down where that's coming from and getting rid of it in the meantime.
So can you go back over that one more time? So 20 to 30 parts per billion. The exposure in our normal everyday life is way more than what that is.
that is my opinion.
Yep.
I, I couldn't point to a spot in a textbook or, but that is,
That's the common sense approach.
that's what's being considered. To me, it's like, well, what is your overall PFAS diet as a human being? And
And
where,
we're spending how much money to treat our water, which is how much comparatively? This is the world we live in. Oh my, it's just amazing.
I would just point out though that there's a difference between concentrations in water that you ingest and biosolids that,
Let me
goes
put
into
my
the
mask
soil
on,
and that sort of thing. But
disease.
yeah, the testing methods are different. And in water, we say parts per trillion, and we're looking at, I believe it's nanograms per liter.
Yep.
In biosolids, you got to switch gears, and you're talking micrograms per kilogram of mass. So it's two different animals. But there are people looking at, even in drinking water, what portion of our total PFAS diet is coming from drinking water. And I'm a wastewater expert, not a water expert. So we need time.
You just,
Well, and the thing about the PFAS diet is when you talk about like drinking water, bottled water has it. But so the thing about that is not just about what you ingest. I mean, your PFAS diet it's in your clothes, it's in your shampoo and your lotions, whatever you're doing in your daily life. That's what it is. So it's not necessarily, and actually, I would say that's worse than the ingesting part of it because that's in your system when you're ingesting and it just goes through you. But primarily.
yeah,
But
that's why I'm
so,
saying you
yeah.
could probably tolerate a higher amount in a biosolid than you could in a water or a product of your, whatever.
well, I'm thinking you tolerate a lot more in your water versus, no, never mind. Anyway, the idiocy that we have to deal with trying to jump because of the, oh, well, never mind.
The other question I had was if we do add this other dryer, we go with option 5. And let's say we have no alternative, like Glacier Gold is gone, and we have to just do work it out with the landfill. Will that entire product be able to? Will they be able to accept all of that? And that's probably something for a future discussion, but that's what we're looking at potentially is we're not able to get Glacier Gold to hang on for a while and they're gone. But we have no alternative but to, try to, get the landfill to take it like 100%.
I would just say to that, our job is to take your waste and we'll do that. We just have to have a long-term plan. So if that happens, we're here.
Okay.
So.
And Dave, if you don't mind, once again, just to remind, we know our plan is like for another 80 years, but.
Yeah, so we are, right now, DEQ, I'm waiting for a letter back that says, okay, we've submitted an application to expand the landfill. We should have somewhere, it depends on how we grow, but 80 to 90 to 100 years of capacity once I'm done with this expansion project. I'm hoping that's in the next 6 months is when we're done with that. And we will have disposal space secured for this county for incredible planning horizon for solid waste. So I don't see a problem there. I think, quite honestly, the problem lies in the day-to-day operations of being able to handle it. There's my concern. It's not the long term, it's the short term.
So a drier product would be easier for you?
Oh, absolutely. There's no question. There's no question.
Okay.
Totally concur with staff and your consultant statement on the capital costs. And I was pushing that when we had our couple of meetings of, man, we got to look at the O&M, look at the long term of this. And they did a great job in that slide. So I get that. But from our perspective, absolutely. What Whitefish brings us when they haul every year roughly. Sometimes it's been every other year in the summertime. They call and say, we're going to haul. And we said, come on in. It's dirt. That's all it is. They come in end dumps, they dump it, we push it up, and it's over. It's absolutely nothing different than dirt. The dust idea, for as few trucks as the slideshow when you got drier and drier were coming in. For me, if we do end up with a dust concern in the summertime, we'll know you're coming. We'll work with Aaron. We can dig a hole just like we do when we take the evidence from the sheriff's office. We dig a hole and bury that right away because it's got all the bad stuff from a crime in it. That's evidence that's ready to bury. I'll dig a hole and dump in your dirt, biosolids, and cover it up and walk away. That's nothing. That's nothing for us. So that's easy. So the dust concern is extremely minimal from our perspective when it comes down to it. And again, I'd even look, if we have to, I work with Aaron and bring us a truck at 7 a.m. I don't open till 8, but if I have a health and safety issue, I'll take a truck at 7 and bring it in, something like that. We'll figure something out. That's all doable. I don't have a problem with that at all.
Kind of get in the sense that 5 makes the most sense at this point, but long range we'll be looking, but I mean, really, we look at it, Mr. Russell, we have to bond to pay for this, to look at these other solutions.
Yeah, we'd recommend going forward with 5 in the dewatering and, designing it as has been discussed here by council very appropriately to have that ability to bring in the drying component as well if need be later on. And so kind of looking for that guidance from council if he wants to move forward in that direction, we can start that process and get moving on it to bring in that additional dewatering. And Susie, correct me if we need anything else that you're looking for.
Nope, I just wanted a general consensus to move forward with alternative 5. Best case scenario, in a year and a half, we transition, we improve our dewatering, and it's an acceptable level for the landfill, and they're able to work with it from here on out. If they determine that they need a little drier biosolids from us, then we'll move forward with installing a dryer. So I think we set ourselves up for that process. Just wanted to review all the alternatives with council and kind of hear what everybody's thoughts were.
And I know you don't know how long, but if you had to guess, if we go 5, which I totally agree with, 5 is to me the obvious one to go with. I hope whatever we do in 5, we're planning for the drying, but how long are you thinking? Like within 10 years, within 20 years? Potential of having to go to a dryer?
Well, if the dewatering at 18 to 20% is acceptable to the landfill and they're able to incorporate that into their everyday operations without the mishaps of having to deal with sloppy biosolids, then we would look to do that forever. If they say, no, sorry, Kalispell, we'd like it to be drier than the 18 to 20%, we would ask the landfill to give us another couple years we would still have to do the same thing, design, bid, build, and bring it in. So to transition to a dryer facility.
Okay.
But time will tell, as a part of the process, if we get our equipment installed by 2026, usually takes us a good 6 months to fine tune our operations and understand what we're doing. And, we'll work our hardest to get as dry biosolids as we can for the landfill.
Mm-hmm.
I really for everybody, because I think ultimately going forward, if we could produce biosolids that was acceptable just with dewatering that is acceptable to the landfill, it's kind of a win-win for everybody in that regards.
If the is the reason adding the second drying the second dewatering machine giving us a drier product, is that because we're able to run the process longer on you have the same amount of material moving through, but it's being split in 2 and it's going through slower, so it does more drying or something? Is that why it's a drier product?
Yeah, I think Aaron could probably speak better to this as to what he did to get that test truckload they worked with Dave on.
Well, with the new volute press would actually be an upgrade from what we have now. So when we purchased that volute screw press, that was the biggest drum size that they produced at that time. They've went from that 12 up to an 18 now, and you can get 4 screws instead of 3. So adding this diameter size and the 4th screw, we can actually that press will actually run super slow, and the slower you can run that, the better products you have coming out of that. So that would be our main unit that we would use on a regular basis. And then the current screw press we would use as when we're tank cleaning or something like that, we could use that. Also, that'd be a backup. But the whole intent is the slower you run that, the drier and the better the product that comes out of that screw press.
So I guess my question was leading to this. Would adding a third one even give us a drier product? Because we could run everything through slower in each one?
You're replacing one, you're not adding.
You're not running them in line.
Correct. We would just be replacing the belt press with the new volute press.
Okay, all right.
Yeah.
I got you. You're not running two. You're only using the one if you're cleaning the tank or whatever.
That's correct. And that's what the belt press is currently right now. If we build a big enough mass in the process that we have to get rid of stuff, which is typically in the springtime, then we'll use the belt press as kind of a catch-up type thing. But the issue with that is that's not a very dry product. So you're pushing it through to get rid of material so it doesn't go out the effluent. So it's a little bit wetter.
Okay, gotcha.
Yep. So the volute screw press will help day-to-day operations, but also in that product that comes out of there.
The picture on 5 looked like 2 of them running side by side the whole time. So that's why I got confused. Appreciate the info.
Yes.
Just a question on the cost. I think I know the answer to this, but on the between 5 and 2, alternative 2 is 17 million. Alternative 5 is just under 3 million. But you had mentioned that if we went with a dryer, we would probably go with a new press anyways. Does the 17 include the 3 million of a new press, or is that on top of?
That includes the new press.
It does include it. Okay.
So throw that like 14.
Yeah.
Yeah, it kind of speaks to the need that's there anyway. It's just a little bit of synergy that it may be your final solution, but it's also something that's needed soon regardless.
Yeah.
And it is a larger volute press than what Aaron has out there now. But I also want to say that it's not infinite. Like you can't slow this thing down and get to a 30%. It just doesn't. The tech is incapable, and a lot of it's because those solids just want to retain some moisture, especially the cells. Won't give that water up. So it's there is a cap of what you can get out of that equipment.
Yeah. Well, that's good to know because I thought I knew the answer to that and I was wrong. So I'm glad I asked.
Anything else from council?
And this still could change with whenever this new EPA number comes out that's supposed to be that we're waiting on.
I don't believe the EPA is going to come out with a number. I think they're going to come out with a risk assessment to
Whatever
the farmer of using biosolids and probably some guidelines and then leave it up to the states. And until they get into Dave's world and start talking to landfills about what PFAS, and I don't know how they would control that, right? Because there's so much of it coming out of our houses and industries right now that I don't honestly see how that would impact this pathway.
And I guess where I was kind of actually more leading that to is really just a thank you guys for all you do, because here we are yet again getting ahead of this when we don't have to do those measures, take those measures. We're doing everything we can to protect our beautiful streams and lakes and everything that we get to enjoy around here. So to everyone at the city down there, thank you for all you do. Thank you for your information, sir. And then David, the county, everything that you do. So I think that's it. What I'm hearing out of this is we do the right thing, even if we're not required to. And I appreciate that and thank you all for that.
Anything else?
Okay.
Public comment on this item?
Good evening and thank you. Mary Flowers, Citizens for a Better Flathead. And as you're probably aware, we have been looking at this issue of disposal of biosolids and septic waste, working with the county to try to address the issues with the lakeside system and the septic system septic receiving station that's being proposed there, as well as the groundwater injection permit. If you're not aware, just this morning, DEQ opened a public comment period for 30 days on the groundwater discharge permit that the Lakeside Sewer and Water District is requesting, as well as on the EA for that also includes their septic receiving facility. So that'll be a 30-day comment that I really hope the city will give, as well as the public at large. But there are a number of issues I think that the city needs to take into consideration. One is that you have one of your main water supply wells at Old School Station. Is that the name of that well, Susie? Which provides a large volume of water for your city. We are talking about a major expansion of the waste going into the Lakeside Sewer and Water District. Currently, the sewage that they collect from along the lake is put in holding ponds and then spray applied to alfalfa crops. What they're proposing to do now is to take additional volume and to do a groundwater injection ponds. That's a very shallow area with high groundwater. And we are concerned that that is probably the worst place in the valley for that proposal to be made for that kind of expansion. And when you look at the cone of depression that's created by high capacity wells like the Old School Station well, you are bringing in groundwater from underneath that area. The Montana Bureau of Mines and Geology just released some new studies kind of refuting the thought that if you're in the deep aquifer, you don't have a connection to the shallow aquifer. And so all of these factors are coming together, and I think it should be of concern how your well is protected, what kind of considerations ought to be taken in this environmental assessment. And again, it was just released this morning, so I haven't been through it to look at those issues carefully, but I hope you and your staff will, because it's a big issue. It's also a big issue with other high capacity wells being proposed in that area. And there's one a little further down in Summers where it's they're going to have to be, they're proposing to put in another high capacity well there, one at Cooper Farms. You get all those wells changing the groundwater patterns there. It's a issue of concern I think that you need to be paying attention to. So I encourage you, and we will be forwarding to you information so that hopefully you will have time to begin. It's a horrible time for public comment. Why the state picks Christmas to ask the public to comment within 30 days is beyond me. The other issue, and let me say, I appreciated this very in-depth presentation today. I have not had a chance to read through it. Didn't realize this was on your agenda tonight, so I'm coming a little bit flat-footed in that respect. But as you're aware, we worked with the county when they were looking at doing the composting and suggested an energy alternative as a option. And at that point, there was a firm in Washington State that was building off a technology that Bill Gates Foundation had developed to take that waste and turn it into an energy product that could then be sold or utilized for like in a cement kiln or an other. It could also be used as a fertilizer. And they were at the point where the heat that they were using, they were still doing testing to see how much of the PFAS it removed. In the end, that kind of came to a roadblock because they were building a facility for a larger volume of waste to handle. And so what Lakeside was proposing to take was a smaller amount than what they could deal with. But the technology, I think, is sound. And since that time, Mark and I sat down probably almost a year ago. And when you guys went back to DC for your League of Cities meeting last year, and there is a town in Phoenixville, Pennsylvania, which has now incorporated, it's a town about the size of Kalispell with about the volume of waste. And they have now converted their sewage treatment system into an energy facility that is cutting their cost and is much more environmentally friendly. I think this is a ripe time for you to schedule to do a Zoom interactive call with that community and to really understand. They've got a lot of time now under their belt where they've had that in place to see how successful it is. And I understand that you may have an immediate issue here with dealing with Glacier Gold closing, but I think right now, while you're in the heat and the pressure of that, is when you need to be looking at other alternatives. I haven't heard any discussion of grant opportunities, and I know in the I'm going to get the acronym wrong, but the funding that is available under that's funding a lot of infrastructure projects across the country has had a lot of earmarks for energy-related projects. And I think there is likely some possibility for grants that the city could look at and be a cutting-edge example of opportunity to handle your waste so that it becomes an energy source and a much more environmentally friendly resource. I am going to give you a handout tonight that I just quickly pulled off some of the links that I had over a year ago. And so I haven't had a chance to go back and talk to them. But a year ago, I tried to arrange so Mark could even go visit the facility, but it didn't work out with his schedule. But they're very excited, very open to talking to other communities. And I would like to see that be something that goes onto your priority list to get done. Let's see. I also wanted to point out, and Dave left, so he can't hold me accountable if I misstate this, but I think one of the issues with the Flathead County landfill is that they have to recycle all that leachate, and that's the liquid that in the end kind of percolates through the garbage. It includes the liquid that you're bringing, it includes the rain, it includes everything that comes into that facility. And they're limited by the amount of leachate. They don't have any place to take it. They have some holding ponds where they get some evaporation, but keeping that balance. And I know earlier when we had talked to the landfill about some energy options, and they didn't have a place for the water. And so that is a limiting factor. I understand historically there have been talks with the city about can we run a line to your sewage treatment plant to help us with our leachate. And those didn't go forward. That idea was nixed, and I don't know the whole history of that. But again, I think that's another concept. You know, Dave is being incredibly accommodating, I think, for what gives him a real challenge, and why he's here, I think, saying to you that we really need to dewater this more than what we are right now, because he has and he could explain to you better the limits of the leachate collection system they have. But I wanted to make you aware of that as well. It's my understanding, and again, this is something that Chuck and Chad, this is to, I think, a point you raised about having sources of sawdust and wood products in the community to be able to use. That is one of the reasons Glacier Gold was established where it was, because from the old American timber, it had this almost what they thought would be almost an endless source. But it's my understanding one of the reasons they're looking at closing is they've exhausted that source. And when you have to truck that in a long way, then it really upsets your cost factors. Again, I think we are not only looking at PFAS, but pharmaceuticals are a huge issue. And I think I sent you folks, and I'll resend to you, a presentation that the Yellow Bay Biological Station brought in a speaker to talk about the impact of pharmaceuticals in our wastewater and how that's getting into our streams and rivers and lakes. And right now, there aren't any regulations limiting that. But it's just like PFAS, it's going to hit us, and we need to start thinking of it. It's an issue with the lakeside system because they're only being held accountable for the nitrogens and the nutrients, whereas the PFAS and the pharmaceuticals are not really being considered. But that facility is 1 mile north of Flathead Lake, and the connectivity between the groundwater and the surface water and the sloughs and the rivers and all of that that runs in that area is of great concern. And then a comment on the composting and a factor to keep in mind is that there are so many different situations of where compost is applied. You have very shallow groundwater where there's very little soil to break down some of the components of that compost, be it pharmaceuticals. You have areas, our Flathead landfill, for example, sits on 300 feet of clay before you get anywhere near groundwater. It's one of the best places in the valley it could have been sited. If it had been sited down in Lakeside, you would have seen me pounding on the podium here, because there are places that are probably fine for us to put biosolids in terms of compost, and there are places that are terrible, and particularly with the runoff. So those are just some factors as I'm listening to your discussion that I encourage you to consider. And a couple of questions I have is, how does this process move forward? Does it come to the council for some kind of recommendation and approval? Kudos to the Daily Interlake. It was nice to see that story today. But I think a lot more consideration needs to be given for the public to weigh in on this as well, and to encourage you. And I applaud you, because I think you are a forward-looking council. But I think we would have a standing room only crowd saying, let's do this right. Let's look long-term. Let's figure this out. Yes, number 5 looks like an immediate solution, but let's start right now working on the next phase of that. So I'll pass this out. There are some links on here, web links, and we'll hopefully get you some more information. One other point, the company, which was out of Washington State that we brought in, they had a whole different financing system where they were going to enter into a contract to take that waste stream and there wouldn't be any cost to the county. That was a real appealing part of that process. So I would say, let's not just rule out, go with the cheapest cost. Let's look if there's some other cutting edge entities out there that are proposing ways that you can do this at a much more cost effective level. Any questions on that?
Yeah, bring that over here.
I have them divided out where I could pass them to council and
I'll
pass them
stand
to
it out.
staff.
All goes over to Amy, so she'll.
Thank you.
Thank you. Any other comment? Anything from council? Just
so we're clear, pharmaceuticals are not taken out of our water through our current wastewater treatment plant.
That's correct. But I do believe, majority of it may be deposited in our biosolids. Is that correct?
Yeah, you don't, wastewater treatment plants do get a little bit of pharmaceutical destruction. It just depends on the pharmaceutical. But there are many that pass through there virtually unchanged or untouched, but some are absorbed into your biosolids. And yeah, but it depends on which compounds we're talking about.
Yep. Treatment plants were never really thought to remove of those types of materials, when we were treating, when they were first established, right?
Right.
So,
I guess
Thank you.
I'd follow up on the public comment with two questions. One, have we looked at our old school station well and what the county is proposing and whether or not there's concern there?
I haven't had an opportunity to review the environmental assessment that she pointed out, so.
Okay.
I
I would encourage that because certainly I know the point she's making about the shallow groundwater. I've seen those maps in my own work, and I know that is accurate, that there's very shallow groundwater, and also her statement about the connection between the shallow aquifer and the deep aquifer, that they have discovered that there are places in the valley where there is a connection, hydrological connection there that they didn't think before necessarily there was. So I can confirm that as well. And then the second question is, she didn't provide a name of the community, but this example of energy use, are we familiar with that? Have we looked at that? Is that 3 or 4 here in the alternatives? Do we know? I'm curious if we've assessed the proposal that she was bringing up.
If what she's referring to is on the sheet, no. We suspected at first that it was the eco remedy that's behind one of the pyrolysis and gasification technologies that we believe is getting Gates Foundation money, but we're commenting that to even get to energy neutral on your project, they needed to drive off more water. It's really hard to make energy out of a wet product, so you got to drive the water off first. So even to get to energy neutral, eco remedy said you'd have to be at 18% plus biosolids. So you still have to dewater it. We can look at this. I'm not familiar with this, but some of these, I would question, are they operating on municipal biosolids, or, you can go get more fuel with ag waste, for example, other waste products. So sometimes those energy projects need more energy in the biomass to produce energy. And the eco remedy pyrolysis and gasification was the closest come to trying to make a biochar and be energy efficient and all that. And you see there, the capital cost is $55 million, which, pays for a tremendous amount of electricity, which more and more is coming from renewables anyway. So, if there was a technology that was proven right now that could take biomass or sludge from a city the size of Kalispell and produce energy, I think we would see it being adopted left and right. And we're not just there yet. I'm not saying we won't eventually get there, but we're not there at this point in time. And unfortunately, you all don't have a whole lot of time.
Correct.
And the project that we're all recommending and seeing the logic of would be necessary regardless. It's still the point.
Thank you.
We'll take a look at what you provided and kind of assess this. The first time I've seen this type of process. So
Yeah, maybe just an email that's one page, kind of here's some initial reactions to it would be, I'd find interesting.
Anything else from council? Mr. Russell?
Yeah, a few items. One, and I'll try and be brief because I know we have a subcommittee meeting after this. Do have several items on upcoming agendas. One of them fits right into discussion we've had as it relates to some of the regulatory components related to PFAS and where they're going, and what you're seeing right now in biosolids is somewhere where we've been with the drinking water. And so this discussion really isn't related to the pros and cons of that regulation, because there is a regulation now. But this kind of thought process stemmed from some questions forwarded over by the Interlake related to testing sites and well locations. And we started looking at it and thinking about really in all the information that's gone out, we haven't had just that one good provision of where we started at and where we've ended up at. And Sam, I appreciate your comments in terms of taking that approach and moving forward. So we just thought it'd be a really good time to go over really that timeline and discuss kind of where we've been and how we've worked through really a state. And then I appreciate Susie's term that she used earlier of regulatory limbo, of just not knowing what that regulation is going to be, not knowing really the components within our own system. And that has gotten murkier since the beginning of the process until really just this last spring when we had repeated tests going forward, as even more towards even the summer at the Grandview station when we were doing the installation. So I just want to take, 5-7 minutes just to kind of go over that timeline, because I think it paints a really good story in terms of where we started at to where we're at. So in the winter, and this is kind of leading up to a work session we're going to have in January on the next steps related to mitigation, and kind of very similar probably to what we heard tonight in terms of alternatives for moving forward. While we have the treatment facility in place, we're looking longer term. And, that was part of the discussion when we approved that treatment facility is, okay, where are we going to go long term so we don't have disposal costs, potential capital improvements. So that is going to come in January. So kind of as a precursor, just kind of start out where we've been and what all has actually occurred. So, and I know you've heard a lot of this, and a lot of it's on the website, nothing really new, but some details that I think are very important that just have not been published. And so really kind of wanted to hit that. But in the winter and spring of 2022, the city elected to participate in voluntary testing at the request of the state. They had funding set aside to try and collect data on PFAS throughout the state. We anticipated EPA regulation. We expected that to be proposed in fall of 22 and a final rule in 2023. So our Public Works Department went ahead and initiated that voluntary testing, had 5 test sites that participated in that, and one site had a detect of PFAS, and that was at the Armory Well. As you know, and we've said this before, it came as a complete surprise based upon, our aquifer and our water quality. Joe Schrader was able to quickly contact the state to get a second test in place under that state funding program. So got that scheduled because we really wanted to try and confirm what is the issue, and is there confirmation related to it. Had that second test, that showed a detect as well. At that point, the state funding went away, as did their testing program. So during that time, that summer and fall of 22, we held a council meeting to go over all of the emerging contaminants, including the PFAS. Talked about the lead and copper rule that has been evolving since then, talked about manganese, and had an in-depth discussion on PFAS at that council meeting, including the 2 test results. And at that time, we really talked about the need to try and establish some reliability in our testing components. Really, this is a new emerging component. So we talked about continuing on testing, even though the state funding program had gone away. We're not under an EPA rule related to PFAS, but we really wanted to expand the testing and find out what we're looking at system-wide. Which brings us to the winter and spring of 23. And along our desire to expand our testing, it becomes evident with what is called the UCMR, the Unregulated Contaminant Monitoring Rule. EPA produces one, I believe, every 5 years. And that was issued in 2021. So we had through 2025 to do testing for whatever contaminants they had within there. They've done a wide variety over the years. We did our testing in 2023, and all of our previous testing for the UCMRs were done at one location where we blended the water from our north and south zones. That was at the Buffalo Hill tank. Would almost guarantee you at any point in time, we can take a test from there and it's not going to show PFAS. What we did is we expanded that UCMR testing and enhanced it, and really are making that commitment going into the future of instead of that one site of blended water, we tested 8 of our well sites at that time because we wanted to know what was it within the system. All 8 of those test sites came back free from the presence of PFAS, which, again, like I said, it just got murkier as we were going forward. That the UCMRs requires a second test, which we performed in January. So that's good to create some more of that trend line of data, which again is what we went back as in our meeting in October of 22. So we did the second test, and we had the 2 detects at that point in the summer of 23. We had tested a detect again at Armory Well, and then the first time at Grandview. Again, we were coming off the January test, which had no detects. Again, just a matter of confusion. We had inconsistent tests, and the reliability were of concern. Just getting used to test protocols. We still had lab delays, or not, I shouldn't say delays, but limited lab availabilities. So really just trying to work through all those things. We're wondering if there was contamination of the samples. We're wondering if there's seasonal issues related on. So really wanted to continue doing those repeat testing throughout our continued program. So in the summer and fall of 23, we had those tests. With the UCMR, we were preparing data to be released in the annual Consumer Confidence Report, and including enhanced information both on lead and copper and on PFAS. And that report always gets distributed at the end of the year. So if you're looking at the 23 report, scheduled to be released in 24. Again, we're in the fall of 23 and still no EPA rule. And that is one of the challenges we had that creates that regulatory limbo where we wanted to know what are those expectations going to be. But even in the midst of that, started discussions with the state regarding potential funding options. Obviously, this is going around. We wanted to identify, okay, if we continue to have these tests, where is it going to be? And wanted to prepare ourselves on priority listing. Get into the winter and spring of 24. That's when the Daily Montana published the articles on PFAS and the test results we had. Through questions coming from the public, we set up a series of public meetings and a website dashboard that's evolving based upon a lot of the questions we were hearing and information that the public wanted and keeping up to date. So those were occurring in the winter of 24. And I think I think those were in February. And early March, we had a contingency that did go back to DC for National League of Cities, where we were able to actually set up a meeting with Mark, Sandy, Chad, and myself with one of the head directors of the EPA, who was actually on the committee that was establishing the rule. Able to have that meeting with them, overall, a good meeting in terms of the actual situation that we are looking at in Kalispell, but still wouldn't commit to an EPA rule coming out or what the limits would even be. Again, gave us confidence in where we are with it and within our system, but again, kind of lacking that information, even in meeting with them. Had additional testing occurring in March, again, hitting all the different well sites. So I think that was at the end of March. And at that time, we had Armory hit again, Grandview hit again. So again, we're starting to establish some consistency with those. Also had Old School Station showed a detect for the first time. Again, that just kind of makes us scratch our head on why these are occurring. Finally, though, the EPA rule gets released. And with that ruling, the Armory well and Old School Station are under the regulatory limits of it. The Grandview well would be the only one that was above it. And part of that was, we separated out the two well sites instead of the combined, Adam. So we were able to kind of isolate, which is good knowing for our system of where it's at and what those specific measures were. But because we were already doing all that work, we were able to immediately work with the state on their funding program for emergency contaminants, and held another council meeting with representatives from DEQ to go over potential alternatives, to review our treatment options and move forward with mitigation at Grandview at that time, which is the facility that we have in place, which leads us to the summer and fall of 2024. Again, we had an emergency procurement authorized by council for the PFAS treatment facility at Grandview. And one of those keys is all that funding came from federal state sources. So our mitigation was free from our local taxpayer. And again, that's one of the things we talked about in 2022 is, hey, let's keep going and getting these reviews in place, continue the broadening our testing. So we're in line when we know something occurs, which we were right after that EPA rule got released. But what's also great about it is in that summer and fall of 24, we had a facility designed, approved, and funded and installed and began operation this fall. And in our testing of it, we had PFAS coming into the treatment facility and no PFAS coming out of the facility where it enters our water stream. So in that short period of time, we were able to bring our entire system under the EPA rules and regulations that had finally been released. Now comes the winter of 25. Upcoming, we'll have the work session on what those next steps then are and how that fits into our overall program. Some of the questions that I think are easier because we have access to potential federal funding is things like, what do we do with Armory well and Grandview Grandview still, or not Grandview, but Old School Station, if it continues to show detects and they're under that, regulatory limit. Right now, early thing is if we have access to those federal funds, we'd say maybe take advantage of them and expand our system and address it. That's one of the challenges of this whole regulatory limbo is those initial testing showed those detects and brings about, the concern. And, the EPA, when we met with them, they were talking about, some municipalities that had shut systems down that would have fallen under the regulatory limits and they're just not going to bring them back. And the challenge of that and the risk benefit and return on investment. So those are some of the questions, that we'll present in January of where do we go with these. Again, if we have access to the federal funds related to it, we're like, hey, let's expand our system as good as we can and, take any well that has detection and try and look at those. But, those will be more of the discussion in January. But really wanted to go over kind of where we are at from that winter, spring of 2022, where it all started with the voluntary program, how we expanded it out. And in reality, right now, the state has yet to adopt the EPA rule. They will. It just takes time to go through that process. But there's 3 years of compliance monitoring before anything has to come in to compliance. And I think that's what we started in 22 is really trying to get a handle on where we were, because all throughout that time, there just wasn't a confidence of really what was going on with our system. Now we feel better about it, especially with that rule in place. But now, instead of having 3 years to do that compliance monitoring, we've really already got a good handle on the system of where we're going, and a system that is under all EPA regulations. So just wanted to hit that up. I think it was a good time between not only the upcoming meeting, but like I say, the questions the Interlake had forwarded over, and just our desire is to get all that information out to the public, because, you know, we've talked about the voluntary system, but I don't think we really ever talked about expanding our UCMR testing from one site, which, like I say, we could probably go up there right now and it's not going to show any PFAS because it's part of the blended system, and expanding that out to 8 different well sites. So just wanted to take the opportunity to run through that. So I appreciate a little bit more of a manager's report than normal, but I think it's also pretty important as a lead into that meeting in January. And following up from our biosolids discussion, which you heard a lot of, we don't know what we don't know. We're not sure what the next steps are going to be, what the EPA rule is going to be. So good opportunity to hit that. Now, that'll probably be the second work session in January. The first one will be the lead and copper funding resolution that was requested previously. Again, EPA regulation. And we'll just review, you know, that options and really an update on the EPA rule and what it means, as we've been able to dive into it more since it was initially released, and some of the timeframes and components related to that. At that first meeting in January, we also plan to talk about property maintenance code, get back to some of the questions as it relates to property maintenance, what can be done within our current code, which is, I'm just going to say honestly, little. Potential securing of it through fire code, which should be modified to make it a little more user friendly for it, but I'll have more discussion on that as we get there. Next week at a regular meeting, we'll return to partnership with the Bibblers on recommended MOU to start off some of the planning and go through that about what that partnership could look like with the potential development of the park. And last thing, as we're talking about the DC trip last year, the Congressional Cities Conference is coming up in March. 3 people that were scheduled in our rotation to go this year were Mark, Jessica, and Jed. Mark has a conflict. I want to put it out to council. Again, this is your training budget. So I'd leave it up to council if you want to seek someone else to appoint to go to those meetings in March. We'll have the Congressional Cities Conference for the majority of it. And then that last day, we'll meet with our congressional delegation on pertinent items related to the city of Kalispell. So looking to do registrations by the end of the year to take advantage of the early bird discounts with it. So I would leave that for council discussion on what do you want to do with Mark's conflict in terms of anyone else taking that spot.
When is it again?
March 9th through the 13th.
Anyone want to raise their hands? Or your calendars, get back to
I'll
Deb.
look at it. I would be
Sounds
interested. I haven't been for how many years now?
Yeah, you've missed out on a couple with conflicts, but
So I'd be
If nobody
interested.
wants to go, I volunteer, but I've been going a lot, so. Just saying.
I'm always down to go bug our federal representatives, so. But I'll let somebody else go since
They won't fly out to this one on their dime.
I know.
Trump will welcome you.
so again, I can't stress enough, this is the decision I don't want to make. This is for council to kind of authorize the individual, because again, it's, we have a rotation in place to give everyone equal opportunity. And this is just an opportunity similar to November when, we did have people with conflicts. I think, Carrie, you had a conflict then, and I think Sam had a conflict. And
I just hope somebody steps up, because Jessica keeps sending me messages. It's only you going. So, so.
So I guess Carrie, you needed to look at it.
Yeah, if Carrie can look
Yeah,
at
I'll
it,
check.
great. And
I need to check my
Yeah.
calendar.
Yeah, I think we've had 3 people express interest, whoever's can go, and then it's been the longest since they participated. It should be the person.
sense to do
Yep.
that.
So maybe we'll bring it back up during manager's report next week at the regular meeting, which will give us time to
Yeah.
go the registration. So, okay, sound good. So then finalize it. Subcommittee meeting in the conference room should be fairly quick as we just go over the allocation model, but it'd be good information for people on that committee. And that is all I have, Your Honor.
Okay. And I'm going to be quiet this week. So with that, we're adjourned. Well, I could go on for hours, but
Yes, you.